So this behind me is the Turing Torso, which is the most famous building in Scandinavia. It's also the tallest one, 190 meters tall, and it's made by the famous Spanish architect Santiago Calatrava. And I'm going to talk about this building in this video and how we can model it in Revit. But first, we're going to talk about the inspiration behind the building, which is an old sculpture by Calatrava, also called Turning Torso, and it is actually showing a stylized human turning torso.
So, as the famous story goes, Calatrava saw this sculpture by Holiday Avery Wilson. Then he was inspired and he did his own, more architectural sculpture, this thing. And maybe the most famous sketch of Calatrava is this comparison between the original sculpture and his sculpture. And since the first video of this series is about the inspiration behind this building, I'm going to put here as a side note Alexander Shipenko, which was famous for his avant-garde sculptures, including the human body, and he had actually many sculptures of turning torsos, which are quite similar to the one by Holiday Avery Wilson. In this video, I'm going to talk about creating these sculptures resembling the human torso in Revit and how to make them parametric. If you're more interested in modeling the actual building, stay tuned for the next two videos. And if you want to see them sooner, please subscribe to my channel, hit that like button if you like my videos, and share them if you think you can help someone with them, because this is going to help me create more videos more often. So this is the model that we're going to create. Actually, my idea is to create a male human torso in this exercise, but here I have used a female human torso. And this is a parametric family in Revit. They are all instances of the same family. There is a rotation parameter, which is 60 degrees in this case. If we make it 0, it's going to turn straight to the front. And these seams are normal for shapes in Revit. And it could have a negative rotation, of course. So it rotates like this. As you can see, the bottom part stays the same. So I think it breaks at 90, but let me put it at minus 89. Yeah. Top part rotates, bottom stays the same, and there is a gradual rotation of the rest. What else? We can make it taller, and there is something weird with the other ones. I mean those ones that rotate in the other direction as well. I'm going to make it slightly differently in this exercise, but I'm going to start pretty much from scratch with creating the new figure. And I got criticized about those exercises. Why am I showing modeling human figures and things that are not so practical? And the first reason is that it is fun. I believe that it is fun, but also when creating something like this, you're learning a lot about form creation, modeling, and techniques in Revit that could be used in other situations as well. So this is made in 2019, but I'm going to create the new model in Revit 2017. So this is Revit 2017, a new mass family, nothing yet so far. It turns out the easiest way to model a human body in Revit is to use a reference from somewhere else. So what I do is I go to free3d.com, I typed human body, and I think I downloaded this free OBJ file, a male figure. So I have downloaded this figure, and one way to import it is to open it in AutoCAD, convert it to the WG file, and then import it in Revit. But today I'm going to try a different approach. Today I'm going to use Dynamo to import the figure, and to do so I need the Mesh Toolkit package. It looks like this. And from the Mesh Toolkit package I use several nodes. The importing file, mesh.reduce, because I don't need high poly file, and also from the Mesh Toolkit pack I use mesh.intersect to slice the figure. So this Dynamo file is going to be sent to all the subscribers of my website, and if you want to subscribe to my website, it's going to be sent to you as well, together with other bonus material. Even though I'm not too concerned about scale in this case, because we are just sculpturing right now, I needed to scale the model so it's not tiny. And this is how the figure looks like in Dynamo after the mesh reduce file, after the mesh reduce node. So something like this. And since it comes from another coordinate system, it's right now lying on its back, so I'm using rotate to make it stand up, and then I'm using geometry translate to put it in the right position above the zero. Then here I'm just creating a bunch of points and then a bunch of planes, and with the mesh.intersect node I'm slicing the mesh with those planes. So here, if I enable the preview of this, it looks like that, because the point starts here and about the middle of his head. But then I don't need his arms, so that's why I'm using a box. Actually, I'm going to keep that preview on. I'm just using Qubit by lens and geometry translate to put a box that cuts only the torso, and I'm using geometry intersect to get only the intersection of that box. And that's pretty much it. I have dropped the list.clean node here, so I'll get rid of all those empty lists. That could occur when the plane is not slicing anything, or cases like this. And the last node here is model curve dot reference curve by curve. It is importing these curves into Revit. So now once the Dynamo graph has been run, we get those lines in Revit. And it depends on your mesh actually what kind of result you're going to get. In this case I got NURBS curves, but then you can get different types of curves, and sometimes you may need to explode the geometry or slice it furthermore, but in this case I just got NURBS curve, so it imports directly in Revit. And probably you would like to just select all of those curves and hit create form, but nah, it's not going to work always. Sometimes it could work, but not now, because there are actually too many of those lines, a different number of lines, and this is a problem for the lofting tools in Revit. And also, if we just loft those lines like this, we're not going to get a parametric figure. It's going to be just a static model. So we are only using those curves for references. Next, I will show you how to actually make this parametric, how to make the rotating parameter of the torso. So what I'm going to do now, I'm going to place 3 points in the intersection of those reference planes. Why do I need 3 points there? Actually, I don't need them there. I need to create a reference spline, which is actually going to be the spline in a way of that torso. So I'm just going to drag one of the points to around the top. Doesn't need to be exactly there. The second one is going to be somewhere in the middle, and the third one is going to be someone around the bottom of our figure. And then I'm going to select those 3 points and hit spline my points. Then I'm going to make that spline a reference line. So why do we need this line? Because this line can host points, and those points I'm going to turn on the reference plane have a rotation angle parameter. Why is this important? Because this is what we're going to use now to create the rotation parameter. Now, if I set the plane to this one, now our work plane is the plane defined by this point, and I draw a spline around that to make the neck. And actually, when you do this, you should be careful. Like when you select the spline, you should choose not draw on face, but draw on work plane. Thus, you're making sure that you're drawing on that work plane that is selected now. So let's just make a spline here and another one to finish it. Like this. And you can use these splines to approximate those sections, but I'm not going to use this in the moment. But now, when we change that parameter, we can see that the splines are rotating together with our point. So this is what we're going to use. And I'm going to delete those 2 splines. What I'm going to use instead is a new adaptive family. And I'm just going to create a new family, metric, generic, model adaptive, and I'm going to do the splines here. So I'm going to select the spline through points too, and I'm going to use that middle plane here just as a visual reference, and I'm going to create a spline with 9 points on this side and another one with 9 points on the other side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3. Actually, yeah, we should be keeping the points in the same direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I can select all the points and make them adaptive. So that's a spline with a total of 16 points, as you can see now. And let's try to make it work. I'm going to save it and I'm going to load it into the project. Turning torso concept. As you can see, it's fairly big as I have drawn it, but that doesn't really matter. So to make it work, I need to place this profile on that plane, as you've seen already with the spline. In order to do so, I'm going to select these lines and the plane, and I'm going to isolate them like this. Now I'm going on the top view. I set the plane to this one. I press CM for component, and I just started placing my points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have a relatively good match, and of course you can slide this a little bit if you want to, and I'm going to delete those lines. And thus I'm going to do all the other profiles. Just joking, actually I won't need all of them, but still, let's continue. So here I have my second point, so I'll just isolate the plane and those lines. I go on top view and I press CM again. 1, 2, 3, 4, 5, 6, 7, 8. So here I'm going to speed up the video because I'm basically just doing the same thing, rinse and repeat. You can see I test the profiles if they flex. It's a little bit tedious because we put every profile with all of its 16 points manually based on the work plane of each point. And I didn't use all of the profiles that we got from Dynamo. I actually end up using only 20 profiles. Now 20 profiles times 16 points, yeah, in a way it is a lot, but also I think the whole process took me like 20 minutes or so in real time. So when you think of 20 minutes, it's actually not so much. So not that bad. Yeah, maybe not the most interesting thing, but still it is worthy when you see the result. And now we're left with those 20 profiles. And if you've come that far, I want to congratulate you for your patience. And I would suggest, if you haven't subscribed already, to subscribe, and if you like that video, to press the like button. If you don't like it, to press the other button, but that would definitely help me create more content for this channel. So what's the next step now? I select one of the profiles, I click on select all instances visible in view, so that would select all of the families. And the first thing that I'm going to do is switch off visible. So these profiles, these nested families, are not going to be visible whenever we put that family into. And then I just click on create form. And we are left with that model, which for me it's not bad. And if you click down here, preview visibility, you can switch it on, so you can see that the profiles are invisible. Of course, now we have a shape in Revit, so we can assign it a subcategory or material, whatever. But most important thing is to actually deal with those parameters, because now we have 20 parameters, yes, for all of those 20 profiles. So what do we need to make the torso turn? It's going to be a fairly simple formula. So R1 is the top profile, R1, and I'm going to say that R2, which is the next one, is going to be R1 times 0.9, let's say, and I'm going to copy that. And R3 is going to be R2 times 0.9. R4 is going to be R3 times 0.1, and you get the idea. R5 is R4 times 0.9, R6, and actually, instead of having 0.9, we can create a parameter called new parameter, which is going to be a number, and it's going to be called rotating ratio or something like this, like just ratio. And I'm going to set it to 0.9 at the moment, but then in these formulas I'm just going to substitute it with ratio. So we can change later how much do we want that torso to turn according to the first one. And yes, R6 is R5 times ratio, and that's it. Apply, and I'm going to save this. And now let's test how does it work. I'm going to change the first one to 15 degrees. Let's start slow with 15 degrees. And you can see here it rotates and all the others change accordingly. Let's turn the preview on. Okay, let's make it 30 degrees. Looks like there is a bug here actually. Maybe we didn't apply an angle. Yeah, we definitely did not apply one of our parameters. So let's see which one is that. Looks like that one. Let's go to wireframe mode. And as you can see, we are definitely missing the parameter on that. So the easiest way in this moment to solve this problem is to ignore it and just delete these profiles. And to be honest, I kind of like those results. It looks like something from Salvador Dali. Kind of like it. But we are not looking at Salvador Dali right now, so I'm going to delete this profile and that profile. And I'm going to dissolve the form, select all instances again, and create it without those profiles. And now it looks more like Calatrava. And actually we can try loading it in a project. So this is just a new project I just opened. And just going to load it inside the project and put it somewhere in the middle. All the elements are visible. Anyway, let's go to a 3D view, and you can see, because we used the mass family, this is our model now, and we can actually use mass floors. Do we have, let's go to yeah, we need, I'm just going to put it down here actually, and going to do something like this, and then go to 3D view again. And now we can see that you actually get the floors from this model because it's a mass. And what else you can do? You can go to architecture, floor by face, and you can make an architectural floor on those faces. Yeah, maybe I should have made this bigger. But anyway, you can also go to create a wall by face. Let's get a thin wall and apply it to our shape. And now we have a building out of this sculpture directly in Revit. And then we can still select our mass like this and change the angle to 60 degrees. And we can also select our mass again, select the related host, and click on update to face, which is going to update the walls and the floors. Can keep wall extended to wall. That's understandable when we're talking about walls like this. And of course, if we go and move our levels, the floors are going to move with them and adjust automatically to the shape of our building. Or maybe not right away automatically. We're still going to need to click update to face, but yeah, it adjusts automatically. Well, we can change that wall to brick wall if we want to. It could break at that point because the brick wall is going to be thicker. Can't make face wall shape. Yeah. The only reason this is happening is because our sculpture is too small for a building. But what else can we do? We can actually go and make a curtain system. Create system. Make it here 20 by 20 panels or so. And now we're looking at a Revit curtain system. Shape to our turning torso. And now that really is it. And of course we can just copy this turning torso because it's a family Revit. And because we used instance parameters, we can go and make this 89 degrees. We can go and make another, make it minus 89 degrees, so they look at each other. We can also, as we said, we can give this thing material. And this is it for now, guys. If you want to receive the script for slicing the 3D model, you can receive it upon subscribing for my website if you haven't subscribed already, and I'll make sure to upload the models, the male and the female torso, somewhere on my website, probably on the download section. There might be a symbolic fee for these models, but still, now you know how to model them yourself. So it's up to you. Thank you guys for watching and have a great day. Bye bye.